The definition of medium voltage differs slightly depending on the context and industry. However, it generally refers to electrical voltage levels that fall within a specific range. According to the International Electrotechnical Commission, also known as IEC, medium voltage is defined as 1 kV to 36 kV. According to the Institute of Electrical and Electronics Engineers, also known as IEE, medium voltage is defined as 1 kV to 100 kV. The United States National Electrical Code, also known as NEC, defines medium voltage as 601 volts to 35 kV. The term medium voltage is relative because it depends on the comparison with other voltage ranges. For example, in high-voltage power transmission systems, voltages can exceed 100 kV, making medium voltage levels appear comparatively low. However, in low-voltage applications such as residential and commercial buildings, voltages are typically below 1 kV, making medium voltage levels seem high. Several factors influence the definition of medium voltage. Firstly, historical conventions have played a role. Medium voltage was originally defined as voltages suitable for use in industrial and commercial applications, which typically ranged from 1 kV to 36 kV. Secondly, technical limitations have also influenced the definition. Early electrical equipment and insulation materials limited the practical use of voltages much above 36 kV. Thirdly, safety considerations are important. Higher voltages pose greater safety hazards, so the medium voltage range is often defined to balance the need for higher power transmission with safety concerns. Medium voltage systems are commonly used in various industrial, commercial, and infrastructure applications. These include electric motors and machinery, commercial buildings and large residential complexes, industrial plants and manufacturing facilities, substation distribution networks, and public transportation systems. In more detail, let's consider some of the key aspects of medium voltage systems. Firstly, voltage levels are a critical factor. Medium voltage typically ranges from 601 volts to 35 kV according to the NEC, but other standards like IEC and IEE may define it differently. Secondly, applications are diverse. Medium voltage is used in industrial, commercial, and infrastructure settings to power a variety of equipment and systems. Thirdly, safety is paramount. Working with medium voltage requires specialized training and equipment to prevent electrical hazards. Fourthly, equipment includes transformers, switchgear, cables, and other specialized components designed for medium voltage applications. Fifthly, standards and regulations govern the design, installation, and operation of medium voltage systems to ensure safety and reliability. Sixthly, insulation is critical to prevent electrical breakdowns and ensure safe operation. Seventhly, grounding is essential for safety and to protect equipment from fault currents. Eighthly, protection schemes, such as fuses and circuit breakers, are used to detect and interrupt faults, protecting equipment and personnel. Ninthly, maintenance is vital to ensure the continued safe and reliable operation of medium voltage systems. Tenthly, training is necessary for personnel working with medium voltage equipment to understand the hazards and safe work practices. Now let's elaborate on each of these aspects. Considering voltage levels, the range of medium voltage is defined differently by various organizations. The NEC defines it as 601 volts to 35 kV, while the IEC and IEE have slightly different ranges. It is important to understand which standard applies to a particular situation. Regarding applications, medium voltage systems are used to power large motors in industrial settings, distribute power in commercial buildings, and provide electricity to public transportation systems. The specific voltage level used depends on the application and the load requirements. In terms of safety, working with medium voltage requires specialized training and adherence to strict safety protocols. This includes using personal protective equipment such as insulated gloves and clothing, and following lockout/tagout procedures to de-energize equipment before working on it. When discussing equipment, transformers are used to step down medium voltage to lower voltages for use in buildings and factories. Switchgear is used to control and protect medium voltage circuits. Cables are used to transmit power from one location to another. With respect to standards and regulations, the NEC, IC, and IEEE all have standards and regulations that govern the design, installation, and operation of medium voltage systems. These standards cover everything from the selection of equipment to the installation of wiring to the operation of the system. Regarding insulation, proper insulation is essential to prevent electrical breakdowns and ensure safe operation. Insulation materials must be able to withstand the voltage stresses that occur in medium voltage systems. Considering grounding, proper grounding is essential for safety and to protect equipment from fault currents. Grounding provides a path for fault currents to flow back to the source, which causes the protective devices to operate and to energize the circuit. With respect to protection schemes, fuses and circuit breakers are used to detect and interrupt faults, protecting equipment and personnel. These devices must be properly sized and coordinated to ensure that they operate correctly in the event of a fault. In terms of maintenance, regular maintenance is vital to ensure the continued safe and reliable operation of medium voltage systems. This includes inspecting equipment for damage, testing protective devices, and cleaning insulators. When considering training, personnel working with medium voltage equipment must be properly trained to understand the hazards and safe work practices. This training should include both classroom instruction and hands-on experience. To further clarify, let's delve into the applications of medium voltage in more detail. In industrial plants, medium voltage is used to power large motors, pumps, and other equipment. This equipment often requires high power levels, which are best applied at medium voltage. In commercial buildings, medium voltage is used to distribute power to various loads such as lighting, HVAC systems, and elevators. The medium voltage is typically stepped down to lower voltages for use by these loads. In public transportation systems, medium voltage is used to power trains, subways, and buses. The medium voltage is typically supplied by substations located along the transportation routes. The selection of the appropriate medium voltage level depends on several factors, including the load requirements, the distance the power must be transmitted, and the available equipment. Higher voltages are generally used for longer distances and higher power levels. However, higher voltages also require more expensive equipment and more stringent safety precautions. The design of medium voltage systems must also consider the potential for faults. Faults can occur due to insulation failures, equipment malfunctions, or accidental contact with energized conductors. Protective devices, such as fuses and circuit breakers, are used to detect and interrupt faults, protecting equipment and personnel. The coordination of these protective devices is critical to ensure that they operate correctly in the event of a fault. Medium voltage cables are typically insulated with cross-linked polyethylene, also known as XLPE, or ethylene propylene rubber, also known as EPR. These materials provide excellent electrical insulation and are resistant to moisture and chemicals. The cables are typically shielded to prevent electromagnetic interference and to provide a path for fault currents to flow back to the source. Medium voltage switchgear is used to control and protect medium voltage circuits. Switchgear typically includes circuit breakers, fuses, and other protective devices. The switchgear is designed to isolate faulted circuits and to protect equipment and personnel from electrical hazards. Medium voltage transformers are used to step down medium voltage to lower voltages for use in buildings and factories. The transformers are designed to operate efficiently and reliably under a variety of load conditions. The transformers are typically cooled with oil or air. The operation of medium voltage systems requires specialized training and adherence to strict safety protocols. Personnel working with medium voltage equipment must be properly trained to understand the hazards and safe work practices. This training should include both classroom instruction and hands-on experience. In addition to the technical aspects, there are also regulatory requirements that govern the design, installation, and operation of medium voltage systems. These regulations are intended to ensure the safety of personnel and the public. The NEC, IC, and IEEE all have standards and regulations that govern medium voltage systems. These standards cover everything from the selection of equipment to the installation of wiring to the operation of the system. Compliance with these regulations is essential for ensuring the safe and reliable operation of medium voltage systems. In summary, medium voltage refers to a range of voltage levels that are used in a variety of industrial, commercial, and infrastructure applications. The selection of the appropriate medium voltage level depends on several factors, including the load requirements, the distance the power must be transmitted, and the available equipment. The design, installation, and operation of medium voltage systems must comply with applicable standards and regulations to ensure the safety of personnel and the public.